Hello, Integrated Math 1. Welcome to lesson 2.3.3b. So we're doing the second half of module 1, topic 3, lesson 3. We're doing the other half of it today, so we're going to be doing activities 3.3 and the talk in your workbook today on page, starting on page M2-197. So last time we learned about graphing a linear inequality, and we realized that it was shading half of the plane and that there was a boundary line, and if we had a half an equal sign underneath it, it was a solid boundary line, and if there was no little squashed equal sign underneath it, it was just less than or greater than, then of course it was a dashed boundary line. And we also realized that you could always pick a point and plug it in to see if it works. We usually use 0, 0, but that kind of helped us know which side of the boundary line that we needed to shade on, and so we did an awful lot of that. So we're going to keep playing with that today, just getting a little bit more practice and looking at a different scenario. So Caesar has living relatives in both the United States and Mexico. He is given a prepaid phone card worth $50 for his birthday. The table of values right here shows combinations of minutes for calls within the United States, and notice that we're calling that X. You can even, if you wanted to, on your table on your page there, you can even write a little X up above it. And calls to Mexico, and we're calling those minutes Y. That expend his $50 prepaid phone card. So the first thing we need to do is, of course, we need to write an inequality. Now, I'm not going to deny this one's a little bit tricky because while I do see a y-intercept, right, we have X, we have Y, I do see a y-intercept, I don't see a slope. So I did have to play with this one a little bit, so you may have to play with it a bit too. So go ahead and write an inequality modeling the number of minutes Caesar can use for calls within the United States and for calls to Mexico. So go ahead, hit pause, see if you can get an inequality going, and then hit play when you're ready to check your work. So I'm actually going to start with Mexico. Yes, I want to know the US, but I also need to know the cost. I want to know the cost per minute, so dollars per minute for the US, but I also want to know the dollars per minute for Mexico. And I'm going to start with Mexico only because I see this right here, that it looks like that he spent his whole $50, ooh, wow, I'm already having writing issues. It looks like he spent his entire $50 phone card to do 100 minutes on a phone call to family in Mexico. So I got a calculator. So I'm going to do this 50 divided by 100, and it looks like I got $0.5 per minute. So when making phone calls to Mexico on this prepaid calling card, it looks like it's going to cost about 50 cents a minute. The US is a little bit trickier though. So now that I know this, I'm going to use this to help me figure out my cost per minute for the US. So I can see here, and I'm just going to use this right here. I think it'll make it a little easier. I can see that he did 80 minutes worth of calls to Mexico. So 80 minutes, and we'll multiply that by our 50 cents per minute. And that alone used up, so 80 times 0.5, it looks like that alone used up $40 of his gift card. Well, it's only a $50 gift card. So if I subtract out the $40, that only leaves $10. So $10 got in 50 minutes worth of phone calls in the US. So if we do 10 divided by 50, it looks like when he uses his prepaid phone card in the US, it's going to cost him 20 cents per minute, or $0.2 per minute. Woo, sorry. We're having a few issues. So anyway, this means I can finish it off. So we said that the minutes for the US were X, the minutes for Mexico were Y. So that means I can do 0.2x plus 0.5y, right? Because that was the call for Mexico. And he's only got $50 to spend. So he can spend up to $50, but he can't go over $50 because there's only $50 on the card. So he could use it for less than $50. He could use the whole thing up right up to $50. So we'll say it's less than or equal to 50. Bam. We have an inequality. Yes. All right. So now that we have this lovely inequality, you know what I'm about to ask you to do. Graph the darn thing. So go ahead and hit pause. Graphs are, I'll write it down. Our inequality, what do we have? 0.2x plus 0.5y. We said it was less than or equal to 50. So we talked about this in the last lesson. You may need to flip back a few pages to remind yourself how we do these. So go ahead and graph your lovely inequality. Make sure you label your axes. Hit pause to graph it out and then hit play when you're ready to check your work. Now, because it's in standard form, I like to do the intercept route. So when we are in standard form, I like to say, all right, let's find the x-intercept by plugging in a 0 for y. So I get 0.2x plus 0.5 times 0 is less than or equal. Actually, we're going to use an equal sign, aren't we? We're just going to make it an equal sign since we're trying to graph it right now. Equals 50. That's going to be our boundary line, right? So, of course, 0.5 times 0 is 0, so that's gone. So I have 0.2x equals 50. And I'll grab my calculator because, of course, I need to divide by 0.2 on both sides. Choo. So x equals 50 divided by 0.2 equals 250. So it looks like my x-intercept is going to be at 250. That's important to know when I'm labeling my axes. And of course, we also, whoa, my pen went crazy. I don't know what happened there. We also need our y-intercept. That's also going to help us graph it. So we'll make our y-intercept. That's when x equals 0. So 0.2 times 0 plus 0.5y equals 50. We actually already know this because we actually did work this out. We saw it on the table what the y-intercept was. So that's gone. 0.5y equals 50. And we'll divide both sides by 0.5. And grab a calculator. 50 divided by 0.5 is, of course, 100. And like I said, we kind of already knew that because we saw it on the table. There we go. So this actually tells me a lot because this does tell me about how I want to label these. So when you label your axes, you're going to want to be real careful about that. These are not going to be my best drawings ever, but here's my x-axis. Here's my y-axis. I can do this. This is why you use a straight edge. I don't have a straight edge on this pad, so we just got to work with what we got. Boom. Here's my y-axis. All right, so obviously we're not calling for negative minutes because we're not earning money back on our card. That would be weird. So let's see if we can figure out how to label this. Maybe if we count by, I don't know, by 10, you want to count by 20s? That sounds good. So if we're like, that's 20. So 20, 40, 60, 80, and we'll be like, that's 100. And then 20, 40, 60, 80, so that one's going to be 200. And then 20, 40, 60, 80, so that'll be 300. So it just kind of helps us out a little bit. Guess that means I don't really need this guy right there then. And of course, let's go ahead and do something similar going up this way. So 20, 40, 60, 80, we'll call that 100. 20, 40, 60, 80, we'll call that 200. 20, 40, 60, 80, and so that will be 300. You might have labeled yours a little bit differently, but I was looking at these numbers and realizing that just might be the best way to go. So let's go ahead and plot our intercepts. We said our x-intercept was at 250, so that's going to be directly in the between 200 and 300. We said our y-intercept was 100, which puts us right there. So your graph might end up looking different than mine. If you use different numbers here, that's just how it's going to go. That's kind of the way it is. We do want to connect the dots. Now, be careful when you connect the dots. Remember, dashed line or solid line. I see a little half equal sign, so that means this bad boy is going to be a solid boundary line. So I'm going to make a nice solid boundary line here, connecting my dots. Again, maybe not the best I've ever done, but not the worst either. Oh, except it disappeared after all that. So there's my lovely boundary line. Now, of course, the other trick of all of this is which side do we shade? So I'm going to erase some of this so that I can actually keep going here. I'm kind of running out of space. Sorry, X-intercept. I already got what I needed from you. So we need to figure out which side to shade, right? So I'm going to shade. There we go. Ooh, now I have room to work again. So I do want to figure out which side to shade. We said we often like to use 0, 0. That was usually a good measure, right? So let's go ahead and plug in zeros. So 0.2 times 0 plus 0.5 times 0. And we want to know if it's less than or equal to 50. Well, 0 times 0.2 is 0. 0 times 0.5 is 0. And 0 plus 0 is 0, which is definitely less than or equal to 50. So 0.0 is down here. So that tells me I need to shade on this side of my inequality. So I'm going to shade this side in, shade in. I'm going to shade it all in. So shady. All right, so we've shaded that in. You probably can shade a little better than I can here with my digital pen. It doesn't, it's a little harder to get accurate there. All right, but we've got it shaded in. It does say to make sure we label our axes, so we'll just make sure we say this is minutes in the US, and we'll say this is minutes to call Mexico. And if you've ever called Mexico, you know that it is more expensive to call Mexico than it is to call within the United States, where we already are. I make phone calls to Australia on a regular basis. It's a lot more expensive than calling my neighbor down the street. Now, so we have this lovely graph. This is great. If Caesar, now I have a whole bunch of questions for you. If Caesar speaks with his aunt in Guadalajara, Mexico for 70 minutes using his phone card, how long can he speak with his cousin in New York, which is in the US, using the same card? Go ahead and hit pause, use your inequality, see if you can figure this out, and then hit play when you're ready to check your work. So here's my inequality. Hey. And we're seeing that he spent 70 minutes calling his aunt in Guadalajara. So that means that y equals 70, doesn't it? So what this means for us is that everywhere we see a y, we're going to plug in 70. So we have 0.2x plus 0.5 times 70 is less than or equal to 50. And at this point, I'm going to grab a calculator because I'm not doing this in my head. 0.5 times 70 gives me 35. So I have 0.2x plus 35 is less than or equal to 50. And at this point, I'm going to go ahead and subtract 35 on both sides. So I get 0.2x is less than or equal to 50 minus 35, which is 15. And then, of course, I will divide both sides by 0.222. And I find out that x, did I do that right? 15 divided by 0.2, there we go, is 75. Ooh. So it looks like Caesar can speak with his cousin in New York for up to 75 minutes. Yeah, so he can speak to his cousin in New York for up to 75 minutes. Not more than that, but, you know, for a while. So he can talk to his cousin for 75 minutes or less using his prepaid phone card. What about so many family members to call and only $50 to call them all on? So can Caesar call his uncle in San Antonio, which is in Texas in the United States, for 100 minutes and also call his mother in Juarez, Mexico for 80 minutes using his phone card? Don't forget to explain your reasoning. Hit pause, work it out, and then hit play when you're ready to check your work. All right, so San Antonio is in the United States, so that means X is going to be 100 and Y is going to be 80. So X is 100, Y is 80. So let's plug each of those in. 0.2 times 100 plus 0.5 times 80, and we want it to be less than or equal to 50 because of course it's all he's got on the phone card. And if you grab a calculator, 0.2 times 100 gives you 20, and 0.5 times 80 gives you 40. And you could probably already see there's a problem here. 20 plus 40 is 60. 60 is not less than or equal to 50. That's no good. He went over his minutes. He went over his time. So no, Caesar can't call his uncle in San Antonio for 100 minutes and also call his grandmother in Juarez for 80 minutes using his phone card. That point, 180, is not in the solution set of your linear inequality. And in fact, another way you could have checked this, since the point is 180, is we could have gone back to our graph if you'd wanted to. And we could have been like, okay, here's 100, here's 80. Is that gonna fit the bill? Oh dear. I don't think I did this graph very well. Oh yeah, I did do this graph very well. So if we go over 100 and then we go up 80, 2, 4, 6, 8, you can see that is not in our shaded region. That point is not in our shaded region. It is not a solution. All right. So now that we've called San Antonio, we've called Grandma, or we're trying to. Question number 5, can Cesar call his brother in Mexico City, Mexico for 55 minutes and also call his sister in Denver, Colorado, which is in the United States, for 90 minutes using his phone card? Don't forget to explain why. Hit pause, work it out, and then hit play when you're ready to check your work. All right, so here's our inequality. It looks like X is going to be 90 because that's 90 minutes in the US to Denver, and Y is going to be 55 because it's 55 minutes to his brother in Ciudad Mexico. So let's plug it in, shall we? 0.2 times 90 plus 0.5 times 55, and we need it to be less than or equal to 50. Grabbed my lovely calculator. 0.2 times 90 is 18, and 0.5 times 55 is 27.5, or 27.5. If I add those together, I get 45.5. Ooh, and that should say that it is, sorry, that one's okay. Hang on. I will fix it. That one is less than or equal to 50. So yeah, actually that one does work out. That one's okay. And in fact, if you wanted to double check it, you could see if 90/55 is in the shaded area on your graph, right? We can come back, we can check. 90 would be about here. 50 would be halfway between here and ahead. Oh, yep, there it is. It is definitely within our shaded area. So yeah, that one totally works. So yeah, the point 90/50 is in the solution set of our linear inequality. Cesar can call his brother for 55 minutes and his sister for 90 minutes. Go Cesar. Cesar, maybe you just need a better phone plan. I'm just saying. Really quickly, I'd just like you to take a moment, interpret the meaning of each of these, A, B, and C, points on the line, points under the line, points above the line, points below the line. Go ahead and hit pause. Write down what each of these points represents, and then hit play when you're ready to check your work. So the points on the line are when his minutes and his money adds up to $50 exactly. So that means that the points on the line represent the maximum number of minutes Cesar can spend on a call to Mexico, given the number of minutes he spends on calls depends on the number of minutes he spends on calls in the United States using his prepaid phone card. So the points on the line are the absolute maximum because he's only got $50. That's it. The points above the line for part B, well, if you recall, we didn't shade in the points above the line because he can't spend more than $50. He's only got 50 bucks on the card. So the points above the line represent times in minutes that are impossible for Caesar to spend on calls either to Mexico or to the United States using his prepaid phone card because he just doesn't have enough money on the card. And of course, the points below the line, that's good, right? Those are all good. Those are the ones he can use his card on. So the points below the line represent all the combinations of minutes that Cesar can spend on calls to Mexico and also within the United States using his prepaid phone card. Yay. So let's go ahead and move on to our talk the talk. We have two main activities here we're going to do for the talk the talk. First of all, I want you to take a look at this line, this graph of this linear equation, and you can see they told us this is the graph of x plus y equals 12, so it's just a line. And what I would like you to do is I would like you to use this graph to answer each question. Please notice that for questions 1, 2, and 3, you're not graphing them. You're just describing what you would do to this graph to be able to graph what it's asking you for, all right? So go ahead, hit pause, work out 1, 2, and 3, and then hit play when you're ready to check your work. All right, so yeah, number 1 says describe how to graph x plus y is less than 12. And of course, you got to choose a point to test the region. First of all, I don't see a squashed equal sign there. So the first thing I would change on this is I would change the graph to a dashed line. That's the first thing I would do. And of course, it did say to choose a point to test, which is good because I need to know which way to shade. I like to use 0, 0. So I'm going to use 0, 0. 0 plus 0, x plus y. So 0 plus 0 is, of course, 0, which is less than 12. So that's good. And, of course, that means then that we need to shade below the line. We would be shading the half plane below our line. Yay. What about number 2? Describe how to graph x plus y is less than or equal to 12. And again, choose a point to test the region. So because I see the squashed equal sign, I would keep the solid line. I would keep that graph line. I would keep it solid. Solid as a rock. Yeah. So I would keep my solid graph line. That's good. Let's plug in 0, 0 once again to see which side we have to shade on, although I suspect you already know which side to shade on. So 0 for x, 0 for y, 0 plus 0 is 0, which is less than or equal to 12. Sorry, I lost my squished equal sign, my bad. So that one's also okay, hooray. So again, we would shade the half plane below the line. That includes my origin, my 0, 0. Ooh, last but not least, describe how to graph x plus y is greater than 12. You probably already know what it's going to look like, but you do need to choose a point to test the region. Go ahead and hit pause, write it out, and then hit play when you're ready to check your work. Well, first of all, no squashed equal sign. This bad boy needs to be changed into a dashed line. So I would change the graph to a dashed line. That's the first thing I would do. And of course, it's now greater than, which makes me think I should be shading up above, but I'm going to check real quick with that 0, 0. Of course, 0 plus 0 is 0, which is not greater than 12. So no, I wouldn't be shading this side. In fact, you may have tested with the point over on this side. That's totally fine. I got it. But that does mean we should be shading the half plane above the line. All right, one last activity, one last thing, just to kind of sum it all up and bring it all back together. I have a table for you. Yay. I would like you to complete the table. Go ahead and hit pause to complete the table and then hit play when you're ready to check your work. All right, this says x plus y equals 0, and it wants me to describe my solution set. Well, because it has an equal sign, you know the solutions are just all the points that lie on the line. So all the points that are on the graph line, those are my solutions. This one says x plus y is greater than or equal to 0. So it still includes all the points that are on the graph line, but now it includes the points above it as well. So all points that lie on the graph line and all the points contained in the half plane above the graph line. This one says x plus y is less than or equal to 0. So it still includes the points on the line, but now we're talking about also including all the points contained in the half plane below the graph line. This one says x plus y is greater than 0. Oh, no squashed equal sign. So it doesn't include the line anymore. Ooh, so it doesn't include any points that are on the line. This is now only the points contained in the half plane above the graph line. And you know what this one's going to be then. X plus y is less than 0. Well, then that's all the points contained in the half plane below the graph line. But it does not include any points on the line itself. This was a lot, but I think you're getting the swing of this. I think you're getting the hang of this. So as always, guys, I hope you found this helpful and I hope you found this useful. If you've got questions, concerns, please feel free to email me. Or of course, hit that ask for help button here in the Zoom meeting. Let me know. I'll come in, we'll chat, we'll work it out. And of course, there's always office hours. I'll see you soon, guys. Bye.